Question 19, work power energy worksheet. Car of mass 1250 kg travels along a horizontal straight road. The power of the car's engine is constant and equals to 24 kilowatts, and the resistance to the car motion is equals to R. Okay, so car is moving on a horizontal straight road. Let's in this direction. Driving force is equals to power upon V, we know that. And there's a resisting force mentioned R. Okay. And power is also given 24,000. So let me write 24,000 in the numerator. 24K. Okay. And the resistance to the car motion is constant and equals to R. The car passes through point A on the road with speed of 20 and acceleration 0.32. Find the value of R. Applying Newton's second law, forward force minus backward force is equals to mass times acceleration. Okay, so we know V, which is 20 at A, and we know mass, it is 1250. And we're given the acceleration at A as well, 0.32. So use these and make R the subject, and R should come out to be 800 newtons. Okay. Part 2 says find the acceleration of the car at B. Give your answer in meters per second square, correct to 3 decimal places. Okay, what do you know? We know about B, that at B, the speed is 29.9. So we're going to use a Newton's second law again. So 24,000 power upon V. V is now 29.9. Forward force minus backward force, which is R, which is now 800, is equals to mass, which is 1250. And we have to find A now. Okay. Correct to 3 decimal places. This comes out to be 0.0021404, rounds to 0.002 in 3 decimal places, meters per second square. Okay. Part 3 says show that while the car speed is increasing, it cannot reach 30. Okay, that means the maximum speed has to be 30 or less. Okay, let's find maximum speed. So at maximum speed, we know that the forward force is equals to backward force. So at maximum speed, forward force is equals to backward force. Forward force is 24,000 upon V, backward force is 800. And this shows that the maximum V can be 30, so it cannot exceed 30. The speed of this car cannot exceed 30. Okay, so part 4 is explain why the speed of the car is constant between B and C. Okay, so at B, we know the speed is 29.9. Right. So for part 4, at B, speed is equals to 29.9. And we just saw that maximum speed cannot go beyond 30. So these are very close values. So hence, from B to C, the speed is almost constant, because it varies between 29.9 and 30. Okay, part 4 is done. Part 5 says state a value of approximately constant speed. Okay, so we're saying that the speed is approximately constant. What's going to be its value? Let's just find the average of 30 and 29.9. That would be the approximately constant speed. This is going to be 29.95, and possible error in the value. Okay, so it's 29.9, and we know that it could be anything between 30 and 29.9. So the error would be the difference of this and this. So error is 30 minus 29.95, which is 0.05. So average speed is this, and the error in calculation could be 0.05. Okay. The work done by the car engine during the motion from B to C is 25,000 joule, 2,500 kilojoules. By assuming the speed of car is constant from B to C, find in either order the approximate time taken for car to move from B to C. Okay, so we know the formula for power, work, and time. Power is equals to work over time. Let's use that and get done with part 4, part A. Power is equals to work by time. Power is 24,000. Work done is 12,000, 1,200,000 upon time. Divide these, get the time in seconds. We get 50 seconds. Okay. Part B says find the approximation from the for the distance BC. Okay. How do we do that? We can use the energy formula. That's one way of doing that. What's the energy power formula? It's work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay. Work done by driving force would be this 1,200,000 joules. Okay. Loss in energy. Okay, the journey is on a horizontal distance, so there's no loss in potential energy. And from B to C, the speed is constant as well. So there's no loss in kinetic energy as well. So there's no gain or loss of kinetic energy or gain of loss of potential energy. So these values are 0, 0, and 0. Okay. Work done by resisting force. This would be, we need the force of resistance and the distance that it covers. So force of resistance is given 800 Newton in the question, and the distances covered could be D. Now solve this and use division to get D, which comes out to be 1,500 meters.